Will you?
I've clicked on your.
Oh.
I don't know what that's supposed to show.
Oh, it's just showing an inferior mirage obscuring the bottom of that hill, I think. Yeah, that's what it's showing. Yeah, because you can see here, what it's basically saying, we've got this, what appears to be air, this sort of floating island. And of course, what we've got here is an inferior mirage, which is just what I've demonstrated in Jose's picture and in my picture of the windmill. You get, and the fold line here is clearly about halfway through the, and as you can see, as usual, it's slightly compressed underneath, and you get an inversion of the stuff above the fold line going into the stuff below it. So it's just typical inferior mirage stuff. It's, yeah, so that's well established and well understood.
There we go. I'm just interested to know why Rumpus is denying the fact that there's a truck in this image here. It's the same location, same height. I'm interested to know why he's saying that this inferior mirage that's clearly visible on this top image on an inferior mirage day is hiding the area where the truck is, and that you're saying that obviously the inferior mirage is not hiding stuff, and here we can clearly see it.
I've never disputed that it does hide some stuff, but doesn't account for all the things that are missing due to the curvature of the Earth. There are occasions when it will obscure a little bit, but for instance, in the wind turbine case, where the base goes much, much lower on a mountain that's missing by, you know, thousands of feet, it's well below the horizon. You've just got a little inferior mirage here. Well, yes, and you obscure a little bit of the base. Wow, that's exactly.
We're looking at about 40 foot of obstruction here. This hill over here is essentially 50 feet above sea level, and we're seeing down to around about foot. Anything under 40 feet is hidden. Yeah. This lower part, this stuff over here, all this land here is hidden behind the inferior mirage. You can't deny.
Okay,
you can't
so we're missing.
Deny that the inferior mirage is actually hiding it.
I never did. I never did.
That's cool, because when Jose's presenting it with his building, and we're seeing an inferior mirage like this, which is an incredibly strong inferior mirage. Yeah. Let's be honest.
So that's a biggie. Yeah.
And it is with Jose's as well. You know, that you've got to say that, you know, if we're going to compare like for like, you know, we as flat earthers can assert that the inferior mirage is hiding stuff like this is showing here, and obviously you guys will assert something different.
I'm agreeing with you. I'm agreeing with you. I never said we weren't agreeing with. I've never claimed otherwise.
First and foremost, I have never ever said that we see inferior mirages and compression in the same images. Secondly, I would say that when we see this type of effect, this compression, on days when we see just compression but no inferior mirage, if you imagine that there was an inferior mirage here behind this, blocking this out, this is my assertion in this respect, that from the same observation heights, you know, we're going to see an inferior mirage on one day, or we're going to see compression on another. And behind the inferior mirage, when you're actually seeing things, when you're actually seeing an inferior mirage, is it possible that this compression is also taking place behind it, except we cannot see it, although we cannot see it because the inferior mirage is there?
No.
Well,
you're not an expert.
I am an expert on this.
No, you're not. You couldn't even explain Jose's. You admitted you were confused by that. So
by certain aspects.
You don't know everything about life. You don't know everything.
No. There are certain aspects of Jose's thing that I do understand this part.
But you also know that the top part of the boat retains the same size.
No, it doesn't. No, it's also compressed. It's just not quite as compressed as much as the bottom.
I might have some other images that I can show you that's actually a fallacious argument, but I've shown these plenty of times. I've actually cropped out images of the top part of this boat and the top part of this, and they match up perfectly.
Well, you can see from
the major compression.
Well, overlay. Okay, look, I'll take your image now. I'll go do a screen grab.
Here goes Ranty with the punchline. Rumpus, hold on. He say the major part, and go ahead, Ranty.
The major compression takes part on the lower part of the boat. The top part of the boat, in the wider viewing angles, stays relatively the same. The lower part gets all the compression. Now, if we apply that same logic to the wind turbines, then
yes, they're not showing
exactly
any compression. They're not showing any compression.
No, but you've seen an inferior mirage.
Yeah, which you've agreed you don't get on the same day as compression, so that's irrelevant.
So behind the inferior mirage, is the compression.
Behind it, we're looking. What are you
Yeah,
talking
but
about?
I gotta give this to Ranty, because how, Rumpus, how are you saying we cannot get compression and an inferior mirage in the same day? How do we know this? Can we be looking at an inferior mirage, remove that mirage layer, and knowing is a compression or not? We really don't know. I mean, we cannot say no for sure because we really don't know.
You can. The physics says no, and the evidence says no. There's no example of it happening in the same picture as Ranty's agreed.
How would you know?
Physics says
How would you know?
Ali, I was in mid-sentence, and the physics says you can't get it either. Go ahead, Ali.
No, I was just going to ask, how did you know it doesn't happen if you can't see behind the inferior mirage? How do you know it never goes on?
Well, what we can see on the, when we can look at an image, it's not there. We only get compression or inferior mirages, and the physics says you won't get them together either.
So what?
So you've no evidence. So you absolutely no basis for what you're saying. You get compression or you get inferior mirages.
On days when we get the inferior mirage, we realise that things are hidden as viewed by the other image that I've presented.
Yeah.
So things are blocked out.
But
We know that things get blocked out. So if there's an inferior mirage here, yes, a small portion. So this small portion, this compressed part here, that's small.
There is no.
So what we would see, so what we would see the big part of the boat at the top, and then we'd have the compression. Let's say that the inferior mirage happened where the blue is, just above the stena line, right? So we get the big part of the boat, and then we did our blink test. What we would say is, well, the bottom of the boat.
Ranty, I have a question really quickly.
The bottom of the boat should be down here, but it's not. It's just compressed behind the inferior mirage.
But
you can't prove that it doesn't happen. We can't prove that it doesn't happen, but there's plenty of proofs that show that this effect does take place. And with you saying before about the inferior mirage, I just completely, and you agreed that obviously like the area where the truck was on those sands was hidden behind the inferior mirage.
Yes.
Did you see the recent video called Panda Boat? You know, that had the Panda Boat in there with the different stripes, similar to this, but obviously you could see the same compression effects of that. It was actually an observation that I'd planned to go down to Wales, North Wales, meet up with some flat earthers, and we actually got out and got there and got on with it. And we got some excellent flat earth proof. Again, it was Panda Boat. It was literally the same as this boat. It was literally the same as this boat. It was literally the same as this.
All you're showing here is compression and inferior mirage. You haven't got a point. You have not got a single point here.
Let me find the image, and we'll just put that little claim to best. You just said that it wasn't a flat earth proof, and I'm just going to debunk that.
All right, but I haven't got anything. But nothing you've presented so far is in any way a flat earth proof of anything.
So you say that you've not seen this yet, then?
Oh yeah, we discussed this the other day, didn't we? I was
wait a minute. You just said you hadn't seen it.
Okay, well, I didn't know what you mean by Panda Boat, but this particular image I went through with you in the same hangout. Don't you remember we went through this? Okay. You're claiming I haven't remembered something. You clearly haven't remembered the discussion we had about it, idiot.
All right, well, hang on. Let me just finish exactly what we're going to say, because we didn't actually get to the point where we got to the point of this is a flat earth proof in this. We didn't get to that point. It's not a flat earth proof. Because you don't think it's a flat earth proof. Do you realise how far away this is, this boat? Because it's actually,
no, I don't.
There you go, you see. But
okay, so really quick, Ranty. So Rumpus, he's about to to present a flat earth proof. Let's hear it. Please do not do the question and answers while he do his short presentation. I want to hear the explanation first. I want to see the footage, and then we can go question and answer. Please, Rumpus, you can mute yourself and others. Please, take a few minutes, Ranty.
You see this white part, the first white part down. So we've got black and then we got white. You see this first white part down here, so the second part of the boat here. So it's evidenced here. And then we've got more. We've got black underneath it, then we've got white, then we've got the hull. Rumpus even agrees with seeing the hull. Well, guess what? The top of that boat to the very top up here is 33 feet. Do you know how much should be hidden? 23 feet by Earth curvature. 23 feet must be hidden. So we see this white part that we're seeing. Anything below that should be hidden to Earth curve. So how come we're seeing the black part here in the middle? How come we're seeing the white part underneath it? How come we're seeing the hull, Rumpus? Because this is not only compression but flat Earth proof. That's why I've even included the details of the boat, how high it was, the distances, everything's included. 3/4 of that boat or 2/3 of that boat should be hidden. But you're even agreeing with seeing down to the hull, and you agreed that we saw down to the hull on our discussion. So if that's the
No,
case, then
we're not seeing down to the hull.
oh, we're not. Oh, we see it. So would you see we're saying that white part then?
We're not seeing the bottom of the boat.
Oh, oh, so you see the front part here?
Can you see in the
little
picture on the left? Can you see the bottom of the water line? We are not seeing that in your image. But
you do realise that this is a close-up image of the boat, and we're obviously if you're looking at the boat, the person that's taking this image is essentially at the mid part of the boat.
Hold on, you seem to get confused here. The boat sits in the same way in the water all the time, unless it's being loaded up to something. Right. So you can see how much where the water line is and how much of the hull there is, even if you allow for the compression.
So
hold on. You had quite a long go. We are not seeing all of the hull, the waterline of the boat. And what's more, we're getting compression. And we know, as in the Isle of Man observation that Anthony Riley did for a year or so ago that I'm explaining, when you get compression, you can see more than the Earth curve calculators, because you only get compression when you have a cold water. Yes, I know I haven't made the presentation yet to you, but when you get compression, that is indicative of super looming, because you get compression and it means you can see much further than the Earth curve calculator tells you. I appreciate the Earth curve calculator tells you you are missing a great wad, but in our ray trace simulation, when you get compression, you can see much further, just as Anthony did on that shore-to-shore observation he did from the Isle of... Hold on, Randy, I haven't quite finished. On that 27th of March last year that he did, when he could see when he's lying on the sand about 12 feet above the waterline, he was able to see Shalag Point 50 kilometers away, even though he was very low down. The Earth curve calculator said you shouldn't be able to see this, but we know that you can do that if you have particular conditions of a cold water and warm air, and in the same conditions you get extreme compression. We know that compression is linked to being able to see much further than the Earth curve calculator tells you, and that's all you've got here. But even in this situation, we can clearly see that there's we can't see the waterline. We're still missing stuff, even though we're in a highly compressed situation.
Have you got a quote for that, Rumpus? 1 minute, Ranty. Sorry. Have you got a quote for what you just said there, Rumpus? You said that with compression we see further. Where did you get that information from?
We worked this out.
Oh, you worked it out, and you're not an expert.
In our ray tracing, yes, I said.
But didn't I explain about ray tracing? It even says that it doesn't replicate reality, so it's a waste of time doing that.
It does, yeah. Well, you didn't understand.
No, you're going to get
what you were describing.
Hammered with that. I'll make sure everybody knows about that. You'll get hammered.
Good. We, doing our ray tracing simulation, we discovered this is how we couldn't, this is what, when Anthony Riley made that observation and he showed that the Earth curve wasn't compatible with the Earth curve calculator, Philip and I were somewhat concerned about this, but just before he made the observation, actually, we'd just been doing the ray tracing on the normal observations he'd made. And so when he came along with that new observation where he was able to see shore to shore over 50 kilometers, we quickly pumped that into our ray tracing, and with the conditions we were able to get for the day, where we discovered it was a cold sea and warm air. And then we discovered, and if you remember the prediction I made before Anthony Riley showed me that video, I said to him, you will get intense compression and to be able to see it. And what happened when he brought up the video of the Isle of Man? There was that intense compression. And when you get compression, like you're showing us now, you can see much further. And in fact, you can see the curvature of the rays is actually greater than the curvature. So it means you could actually see your own bottom in theory. If you could zoom it.
Wow.
If you could see, in theory, when you've got conditions like this, the curvature of the light is actually curving all the way around the Earth. Potentially, you could see your own bottom if you had a zoom. If you could zoom in enough. These are so when you link compression, you'll be able to see much further.
Okay, so wow, that was a lot of words.
Yeah, really quick. Let me welcome Dross, the legend.
Well, it's a bit technical for you. Well, I know it's a bit technical for
you.
Right?
Well, no. What you just basically said is that this is a mirage. This boat wasn't really there.
Everything's a mirage.
Even though we followed the boat, it's on a video. I have video upon video, not just this boat, but lots of other boats moving around. This isn't an image, this is from a video. So everything was being miraged around as a holographic dancing, looming, flat earth proof.
Randy, looming happens all the time.
Wait a minute. We're seeing the hull. I'm saying, and you've just said that we can see further. So would you agree that this image shows that we can see further than the curvature count?
Yes.
Right, great, perfect. So now you go ahead and show me evidence of looming. You go ahead and make something loom up. That's your proof now. That's your challenge. You can talk all you want, you can surmise all you want, you can ray trace all you like, but you go out there,
Well, this is evidence of it.
You make something.
You're showing us, Ranty, an example.
No, this is evidence of
no, it's evidence of super looming. It's evidence.
No, this
looming.
This is my presentation for evidence
wrong.
of flat Earth. You show me something.
This is it here, Ranty. This is evidence of looming.
Go and make something looming. No, it's not. Go and make
evidence of super looming. This is
it.
because when we pump in the numbers of the pressure and density for this condition that Anthony had, and you'll no doubt have here, you'll find you've got a cold sea, a warm air, and when you pump those into our ray tracer, you get heavy compression and you get sort of curve of the light rays that matches the radius of the Earth, which means effectively the Earth can appear flat as a result of these special conditions. And this is evidence that this occurs. It's evidence of super looming.
Show me to.
Can you show us that work then, Rumpus? Can you bring that work to the table? Wait a minute, Ranty. Can you bring that work, just what you've quoted there, can you bring that work to the table and present it to us all?
No,
obviously not.
I can. Yes, I can. In fact, we've done the maths. Okay, well, you wouldn't. I would have to give you an intense presentation. Leave that. We've got, although we've done.
Well, not the now, but I'm saying
yes, we are. Yes, we are going to do that. Yes.
But let me make this clear really quick. To recap, Rumpus can present a lot of math equations. You can do a presentation of math and equation. But do you have any type of like footage that we can see, like with the eyes? You know, it's good to see things.
Yeah,
can you have videos?
This is evidence. This is evidence of superlooming, just as Anthony Riley's footage is evidence of superlooming. And the fact that it gets compressed exactly as we predicted, because we told Anthony, when he said he did this, we told him before he showed us the video, we said, you're going to get compression. And he didn't realize it. It's only when we told him it's going to get compression, he realized this is what happens. And we know from our modeling that when you get compression like this, it means you're seeing much further around the world than the curve than you would normally be, and it's greater than the Earth curve calculator tells you. So whenever you see compression like this, you're seeing further than the Earth curve calculator tells you.
And you can prove that.
Yes, well, as you did, because we know you've done it yourself, Ranty. You've said, hold on, you've said, Ranty.
I want you to provide a test. I want you to literally do a test, like put something on a hill, right, and just behind the hill, just have it so that like there's like a centimetre of it behind the hill, so you just can't see it, and then I want you to film it for days on end and show it me looming up, peeking up behind the hill.
Ranty, that's what you've got on screen.
No,
you've got it on screen now.
How do you know this isn't a flat Earth proof? How do you know we're not just seeing
it?
Because of the compression.
Because of the compression.
Oh, so it's looming compression. It's, hey, Ranty, we've got a new one. It's called looming compression.
Super looming. I call it
super looming compression. Super looming compression from the bottom.
When you get super looming, you also get compression.
And 4 lines.
I have no answer for this.
I know.
Yeah, you do realise that the topography of the land under the oceans has an effect on the water.
No, it doesn't. Jesus Christ, you're an idiot if you think
that. Really? Well, I have an email from a professor who studies things exactly like this, barotropic tides for one, who agrees that it does have an effect on the water at the top.
Oh, might be a millimetre or something. Yeah, great.
Yeah, you do realise that the topography of the land under the oceans has an effect on the water at the top.
No, it doesn't. Jesus Christ, you're an idiot if you think
that. Really? Well, I have an email from a professor who studies things exactly like this, barotropic tides for one, who agrees that it does have an effect on the water at the top.
Oh, might be a millimetre.